So once again, welcome to the TOS classes of physics, and today I am going to discuss a very important topic in 12th class physics CBSE board, and that is the electric flux. तो आज हम डिस्कस करने जा रहे हैं इलेक्ट्रिक फ्लक्स, बट बिफोर टू अंडरस्टैंड इलेक्ट्रिक फ्लक्स वी शुड नो अबाउट एरिया वेक्टर। लेकिन इलेक्ट्रिक फ्लक्स को समझने से पहले जरूरी हमें पता रहे कि एक टर्म हमें समझना पड़ता है, दैट इज एरिया वेक्टर। किसे कहते हैं भाई एरिया वेक्टर? मैंने मान लिया सपोज दिस इज ए रेक्टेंगल surface, ठीक है। I consider this is a rectangular surface and I take a small area element inside it। क्या कंसीडर किया मैंने? स्मॉल एरिया एलिमेंट कंसीडर किया। A vector is associated with this small area element and that is known as area vector। यानी इस स्मॉल एरिया एलिमेंट के साथ में मान लो मैंने इस स्मॉल एरिया एलिमेंट को क्या मान लिया, ds के बराबर मान लिया। इसके साथ एक वेक्टर एसोसिएटेड रहता है, इस वेक्टर को हम कहते हैं एरिया वेक्टर एंड दिस इज द यूनिट वेक्टर। सो एरिया वेक्टर क्या है? एरिया वेक्टर ये है कि to every small area element a vector is associated and that is known as area vector. In generally books it has been written as ds area vector and that is equal to ds n cap, where ds is the magnitude, this is the magnitude of ds, this is magnitude of area vector. And what is n cap? Actually n cap is the यूनिट वेक्टर। एन कैप क्या है भाई? एन कैप यूनिट वेक्टर है विच इज आउटवर्ड एंड नॉर्मल टू द एरिया वेक्टर। इंपॉर्टेंट बात क्या है इसके लिए? दिस इज आउटवर्ड एंड नॉर्मल being making an angle of 90 degree. So the concept of the area vector is clear now. Actually in 11th class you have studied area is a scalar quantity, but here the small area element we can consider that a surface is composed of very small area element. To these area element a vector is associated, that is known as the area vector, and area vector ds is given by ds n cap. ds is the magnitude of area vector and n cap is the unit vector which is normal and outward to the area element. Okay, so that's has been clear to you. Now we are going to come to our next topic and that is electric flux। अब हम डिस्कस करने जा रहे हैं भाई हमारा जो अगला टॉपिक है, दैट इज वेरी इंपॉर्टेंट एंड दैट इज इलेक्ट्रिक फ्लक्स। किसे कहते हैं इलेक्ट्रिक फ्लक्स? इफ यू कम टू नो देन यू कैन सॉर्ट आउट मैनी प्रॉब्लम्स व्हिच आर बेस्ड ऑन electric flux. So here I have to write down the electric flux. Okay, suppose I have considered a surface that is an irregular surface. This is a surface and it has been held inside an electric field। एक electric field है। The surface is held inside the electric field such that electric field lines passes normally to it, then the number of electric field lines which are crossing normally to this surface is known as electric flux। सिंपल डेफिनेशन कि जितने भी इलेक्ट्रिक फील्ड लाइंस इस सरफेस से होकर के नॉर्मली या परपेंडिकुलरली जा रही हैं उनको हम क्या कहेंगे? उनको हम कहेंगे इलेक्ट्रिक फ्लक्स। ओके, बट इफ I change, I suppose the electric field remains same, like this is the electric field, uniform electric field, but this time the irregular surface is like this one and its area vector I consider that is the area vector, and its area vector now making an angle like this one। surface थोड़ी tilt हो जाएगी इस तरह से। this is area vector and this is electric field। suppose this area vector makes an angle of theta degree with the direction of electric field। So I have to write down that small amount of electric flux, so I have to write down here, so what will be the small amount of electric flux which is passing through, कहाँ से जा रहा है भाई, which is passing through a small, I have considered this is a small area vector passing through a small area element. I write down small area element, मैंने मान लिया इस पर ds. So that is equal to d phi is equal to E dot ds. So very simple definition. So that is equal to the dot product of, that is the dot product of electric field and area vector. So here I can define electric flux. The electric flux that is passing through a small area element which is held in a electric field is equal to the dot product of electric field and area vector. Very simple definition. And the next step I can write d phi is equal to EDS. क्या लिख सकता हूँ मैं, EDS cos theta लिख सकता हूँ भाई, because we know that A dot B is equal to AB cos theta. So if I have to write down the net, the total electric flux, total electric flux, मुझे क्या लिखना है भाई, I have to write down the total electric flux that is passing through this whole surface. That should be equal to, किस तरह से लिख सकते हैं, that is equal to the surface integral of electric field over the enclosed surface. सबसे पहले मुझे क्या निकालना है, टोटल इलेक्ट्रिक फ्लक्स निकालना है. तो उसके लिए मैं क्या करूंगा, इस डी फाई को इंटीग्रेट कर दूंगा. कौन सा इंटीग्रेशन कर दूंगा, सरफेस इंटीग्रल. इफ वी डू द सरफेस इंटीग्रल ऑफ डी फाई देन वी गेट द टोटल इलेक्ट्रिक फ्लक्स लिंक्ड विद दिस whole surface. Okay, clear? Now we are going to discuss some of the special cases. Special cases. अब हम डिस्कस करेंगे कुछ स्पेशल cases. Very important. Generally they can be asked in objective type question. Very very important. Okay, so suppose first case, if the value of theta lies between 0 and 90 डिग्री. अगर थीटा की जो वैल्यू है, जिस थीटा की जो वैल्यू है जो कि एरिया एलिमेंट और इलेक्ट्रिक फील्ड के बीच में है, उसकी वैल्यू अगर लाई करती है 0 से 90 डिग्री के बीच में, देन इलेक्ट्रिक फ्लक्स, उस केस में जो इलेक्ट्रिक फ्लक्स है दैट इज पॉजिटिव. वेरी इंपॉर्टेंट. किस केस में पॉजिटिव होगा, when the angle between the area vector and electric field lies between the 0 degree and 90 degree, the electric flux that is linked with the surface which is held in electric field is always positive. Next case, if I have to write down theta is equal to 90 degree, in that case the electric flux is 0. इस केस में इलेक्ट्रिक फ्लक्स हमारा कितना होगा, that is equal to 0. Very very important result. In which case it is 0, it will be 0 when the angle between the area vector and the electric field that is equal to 90. Okay, now we come to the next one. Actually the value of cos 90 is equal to 0. And third, if the value of theta is lying between 90 to 180, you know that in that case the value of cos theta is negative for this one. So here the electric flux is negative. So electric flux is negative. So here we have discussed what is an electric flux. We have studied, we have discussed that a small amount of electric flux linked with a small area element which is held in an electric field is equal to the dot product of E and ds. And how we can calculate the total electric flux, we have to do the surface integral of the small electric flux. And after that, in which case it is positive, this is positive when the value of theta is lying between 0 and 90. इट इज 0 when theta is equal to 90 degree. उस केस में ये क्या होगा, 0 के बराबर होगा. So like this one we can write down in which cases the electric flux is 0, electric flux is positive and electric flux is negative. I hope that you understand it well. Thank you very much. If you have any problem then send your comments in comment box and I will try to sort out your problem as soon as it is possible. And important thing is that one, try to subscribe my channel. मेरे चैनल को सब्सक्राइब करिए because every time you will get a video that is based on the CBSE board for the subject of physics, and I hope that you have understand it well. Thank you. Have a nice day. Thank you very much.